Welcome to the A-axis tutorial for IMOD and eTomo. Here we'll open eTomo at the command line, and then when it opens we can select New Tomogram. Here we need to select our dataset name. I'm just going to move the log file out of the way. So either name is fine. We want dual axis and single frame. Scan the header and then fill in the fiducial diameter, in this case 10 nanometer fiducials. Then we'd like to view the raw image stack for both axes in case there's an image that we need to ignore during the thing. In movie mode, you can middle click the movie through the tilt series. And then we can view the B-axis, make sure everything looks good there. You can use the float and sub area so that it's a little easier to see the high tilts. You look for anything that is way out of focus or way shifted, or maybe the grid bore coming in. Then we can create the com scripts and then go to pre-processing. This removes X-rays from your sample images, so we create the fixed stack. And then we can look at the minimax for the raw stack. This shows you the minimax values on each tilt. And then it shows you the coordinates of where each of those values are. You want to make sure that you don't have any minimum values with zeros. Here's the min-max for the fixed stack. And we can do a side-by-side comparison. So here on the raw stack, on view 9, there was something that they thought was an X-ray. And here we can compare, and we'll see that in fact that X-ray has been erased. So it looks like we've gotten all the X-rays, so we can say use fixed stack and go on to the next step, which is course alignment. And you'll see, if you look on the left, pre-processing is complete, so the color is green. Course alignment is in progress, so it is magenta, and all the rest have not been started, so those colors are red. That gives you a hint about where you are in the series in case you have to close eTomo and start over. So we've generated the course aligned stack, and now we're viewing that aligned stack. This is what we call the pre-alley. Everything looks well aligned. So I'm just going to reposition here. And then we can say done. Now we have to seed, make a seed and track. So we're going to seed the fiducial model. You'll see that it loaded bba.seed, which is a specific model to help us find and track the fiducials. So we have the auto center is on, that's good. And I'm going to use the page up and down buttons and the insert button to find gold that are on opposite views. So if we look here in the yellow circle, we'll see these two are on opposite views, but you also see they just got connected by a line, and that's because I forgot to check automatic new contour. So I can use the delete key to get rid of any extra points, and then I'll select automatic new contour and try again. So now I'm going to page up and down and look for gold particles that are on opposite surfaces. So one will move to the left and then the other will move to the right. And when you're doing these selections, you never want to pick clumps of gold. You always, it's best to try and pick pairs if you can on each surface. And you also want to make sure it's spread out evenly over the image. And you want roughly 20 to 25 gold particles per 1K image. So this is a 1K by 1K, so looks like we're going to end up with 23 particles chosen. We can see that in the IMOD window. Now we want to save, so we can just do File Save, or we can press S as the hotkey. So we're going to track the seed model. And what this does is shows us now in the log window that we have 26 points missing. It means it was unable to track 26 points. So now we're going to open the fiducial model, and you'll see that bba.fid is loaded. And then as I move you through, what I'm looking for are any points that stray off the gold, because now we're going to use that fiducial model to track with, and we'll see that by doing that we now have no points missing. So I can fix it again just to load the newest fiducial model and see that everything looks nice. So I'll say done. Now we're on to final alignment. Here we're going to just calculate and compute the alignment. We can look in our log window. We'll see that we have the residual error and the ratio of measured values to all unknowns. And this button brings all IMOD windows to the front, which can be really useful so that you can find them again. We can view the 3D model. If you middle mouse click and pan the mouse, you can rotate this model so you can see the two surfaces. So the pink or magenta are on one surface and the green are on the other. You can look at residual vectors. So what this shows you is the green is where your model point is, and the red is where it assumes it should be, only times 10. So it's been stretched for visualization. Sometimes you have big residuals like this, and that's just because it's clear that that point is on the wrong gold, and I'm sure we'll have to fix it. So let me just do a little space remodeling here. And this button centers the current point, which will be useful during alignment. So we'll do that. And then I'm going to zoom in using the equals or plus key, and if you want to zoom out you can use the minus key. So now we're going to go to the next big residual, and you'll see that that's our bad point, so we're just going to right click to move it to the correct position. There it is. And I page up and down to check it. Now I'll just again go to the next big residual, and instead of right clicking I'll move it by the residual. So that means that it'll move to the tip of that little red arrow. I'll go to the next big residual, and this time I'm just going to right click to center. Next big residual, I'm going to right click to move it where I think is more of the center. It's hard when these gold overlap each other. So we just do this over and over again. Here I'll use the move point by residual and page up and down to see that in fact it's the right place. You really should double check these. You can also use hotkeys, which is what I'll use from now on. So the apostrophe will go to next big residual. And instead of move point by residual, I'm going to use the hotkey of the semicolon, which are right next to each other. So it's very useful. We have no more residuals, so I'll save and run tilt align. And I think I'm going to add full distortion solutions from the global variables now. Anytime you make changes in the eTomo, you must compute alignment there. So now we can bring up all the IMOD windows with the little button, and then go to next big residual and fix residuals. You can do distortion corrections when you have gold on both surfaces. Another way to move through the points is to use the bracket keys, and that allows you to keep each point that you're moving through active, unlike using page up and down. So here I'm just going to use the hotkeys again to move between. Sometimes I right click to center, which is a little bit better than the suggestion. Using the bracket keys to move through the points on the same contour. And you just keep doing this through each residual. If you look on the bead fixer, the progress bar will tell you how far we are. So we're now at 89%. It's at the bottom of the bead fixer. We're almost finished. It says no more residuals, so I'll say save and run tilt align. Tells us we have 5 to examine, so I'll quickly go through those. And then save and run one more time. It says 0 to examine, no more residuals. So now I'm going to select neighboring views and recompute the alignment. Go to my next big residual. Fix them. This is an iterative process. You might have to do this many times. Some people stop when they see that the residual error really isn't changing much. So here we went from 0.518 to 0.516. So now I can say that feel like we're done, so we can just close the course aligned stack and move on to tomogram positioning. So here we're going to create our sample tomograms, create the boundary model, and using the little arrows at the top we can move through each sample and see that it's too thick, not thick enough. So now I'm going to increase the thickness, recreate the sample tomograms, and then create the boundary model, and now I have enough space between to be able to see the boundaries. It automatically brings us into model mode, which is nice. And then we can middle click to add points. 2 points make a line. So the line must show the boundary of the top and bottom surfaces of the section. So here we go. Now we're on the next part, the middle. And then we hit the little arrow and we go to the bottom. Here we're going to end up with 6 contours after we save the model. We'll have 6 contours with 2 points in each contour. So we can close this now and compute the Z-shift and pitch angles, and then create the final alignment. And then we can say done. Now we need to create the full aligned stack. This applies the image rotation from the tilt axis, so we can view the full aligned stack, and you'll see that it's now rotated so that the gold moves horizontally. And everything looks nice. No tilts are out of place. We can say done. And we can generate the tomogram using back projection. And now I'll just let it zoom right through to 90%. It's done. We'll view the tomogram, and when we movie through it, we'll just see that here's the top surface, and then we'll movie through it in 3D. Then as we go down, we'll see the bottom surface. So this tomogram looks fine, and we're done, and we have now completed the A-axis.